Last class we discussed about the rate of a reaction and what is the unit of the rate of the reaction and factors affecting the rate of the reaction. Okay. So in the today's class we are going to discuss about the rate expression or a rate law and also the different order of the reactions. Okay. So first I will go with the rate law. Rate law or rate expression. Okay. So students, what is this rate law and rate expression means? So listen, if we are considering any reaction that is AA plus BB gives rise to CC plus DD. This is capital A, capital B are the reactants and C and D are the products. And what about this small a, b, c, d means they are the coefficients of the reactants and products. For example, you know, some cases if you want to take in the reaction, 2HI gives rise to H2 plus I2. Okay? N2 plus 3H3 gives rise to 2NH3. That 1, 2, 3 represents what? This coefficient A, B, C, D. Okay? So to this, we know how to write the rate expression. Okay, sorry, rate law. So rate is equal to what? Rate is directly proportional to change in concentration of A or concentration of or dA by dt we may take minus. Correct? Our rate is equal to A or minus dB by dt. Correct? This is again taken as what? This is the coefficient. This is 1 by A. This is 1 by B. Correct? And 1 by C plus dC by dt plus 1 by D dt by dt. This is what? How to write the rate of a reaction. So, what is the difference between this rate of a reaction and rate law or a rate expression means? So, in this reaction, we are comparing the rate with either with the reactant or with the product. Okay? So, that's why this rate is directly proportional to concentration of A and concentration of B. So to the power X and Y we may take. Okay students, this X and Y is not a coefficient. They are not A and B. Okay, the X and Y are not coefficients. So here this decides what? The order of the reaction, whether it is depend or not. Okay, so rate is directly proportional to concentration of A to the concentration of B. Okay, so this rate is what? dR by dt. Why it is dR by dt? Because we are taking reactants here. That's why this is minus dR by dt is directly proportional to concentration of A to the power of X, B to the power of Y. Okay, next listen here. This is dR by dt. To remove this proportionality, we will take K. Okay, that is A to the power of X. This is B to the power of Y. So this is called rate expression. Understand? This is also called as rate law. This one and this one. This is called as rate law and this is called as rate expression. Understand students? So here, this one is called as what? Rate law. This one is rate expression. Okay, so this K is rate constant. K is rate constant. So what is the definition here students? So what is rate law means? The representation of the concentration of the reactants raised to the power. Understand? These powers may or may not be equal to coefficients. Understand? Here what we are writing? The rate is represent the rate law or rate expression is represented by what? Representing the concentration of the reactants raised to some coefficient or some terms. Those terms may or may not be equal to what? That coefficient. It may be equal to A, it may be equal to B, it may not be equal to A or B. Understand? So this is rate law. So this one is rate expression and this one is rate constant. Okay. So students, so if you want the definition for this rate constant, okay. So consider the concentration of A is 1 and concentration of B is concentration of A is 1, concentration of B is also 1 unity. Then apply here, what you will get? Minus dr divided by dt is equal to k, 1 to the power of x, 1 to the power of 1. So 1 to the power of anything is how much? 1 only. Okay, so that is minus dr divided by dt is equal to k, 1 into 1, that is equal to k. Correct? So what is this rate constant? Rate constant is equal to rate of a reaction when all the concentration terms are in unity. Understand? So rate constant is equal to rate of a reaction when all the concentration terms in the rate expression is equal to unity. That is called definition of a rate constant. Okay. So how we are going to write here, students? The rate of a reaction expression is, what is rate law means? The representation of a reaction by concentration of reactants rise to some stoichiometric terms, stoichiometric coefficients. Stoichiometric coefficients, this x and y. That is called as what? Rate law or rate expression. So what is rate constant? Rate constant is equal to rate expression. Rate constant is equal to rate expression when all the concentration terms, concentration terms in rate expression is equal to unity. So this is called as what? Rate constant. Understand, students? Here you know, if you consider this rate constant, this reaction you consider, this one you consider. Okay? If you want equation for this k, what happens here? If you want k, it becomes what? K is equal to rate. That means dr by dt. Consider this or this. Okay? Then what happens? Divided by concentration of A and concentration of B. K becomes this. Okay? So rate means what? Concentration by time. Correct? That is concentration by time into 1 by concentration. This is the unit of the rate of reaction. What is the need of this unit of rate of reaction? I explain later. Now you just remember what is rate law and what is rate constant. Understood? Okay. So the next one is order of a reaction. So students remember. So it is the rate expression. Correct? What is the order of a reaction? Means it is the sum of the terms, the concentration terms raised. Okay, it is the sum of the concentration terms raised in a rate equation. Means here the concentration term raised to x, here the b raised to y. So sum of those raised terms, that is x plus y is equal to what? Order. Understand? So order of a reaction means it is the sum of the concentration terms raised in a rate equation. This one is what? Order of a reaction. So students, consider here the rate law equation, that is rate, consider the equation A plus BB gives rise to CC plus DK. Okay, so here rate is equal to K into A to the power of X, B to the power Y. Okay, so here what is order of the reaction means order is equal to X plus Y. This means is I write the definition, the sum of concentration terms raised in a rate expression. The sum of concentration terms raised in a rate expression is called as order of a reaction. Okay, students? So in this order of a reaction, types are there. Okay? So first one, zero order reaction. Second, first order. Next, second order. And fourth one, pseudo first order. Understand? So in the order of a reaction, four types are there. One is zero order reaction, first order reaction, second order reaction, and the pseudo first order reaction. So what is this? So zero order reaction means here both x and y becomes what? Here x plus y is equal to 0. When it will be equal to 0? When x equal to 0 and y equals to 0. This is equal to 0, this is equal to 0. Okay? Then this is a zero order reaction. If x plus y is equal to 1, then it is a first order reaction. If x plus y is equal to 2, then it is a second order reaction. If x plus y is equal to 2, but it applies only one term, then it is a pseudo first order reaction. Why it is pseudo means false. Okay? Why it is called as pseudo first order? It is a bimolecular reaction, but it shows first order reaction. Okay? I will explain with example, then you will understand easily. Okay, students? So what is zero order reaction? Okay? So first one is zero order reaction. This is important for 2 marks. All these reactions with the example and the definition is equal to how much? Marks? 2 marks. 2 marks important. Any one of the order. Either first, second, pseudo first order, zero order. In that, this pseudo first order is very important for 2 marks. Among these four, pseudo first order is very important. So students here, zero first order. Okay. So I'll take the example here first. Listen. Okay, general reaction I'll take first. A plus BD gives rise to CC plus DD. Okay. So this rate means what? I'll write complete, which is minus dr by dt is equal to k, a to the power 0 and b to the power 0. Okay, if both x and y is 0, so this is completely independent of the concentration of the reactants, then what it becomes? So if you listen, anything to the power 0 is 1, anything to the power 0 is 1, 1 into 1 means that is k. Understand? So rate is equal to rate constant when it is a zero order reaction. Understand? So listen, here what is the definition means? I'll write the reaction in which this rate, correct? This rate is independent of rate is this rate is independent of concentration of reactants. Correct? So what is the zero order reaction? The reaction in which rate is dr by dt is independent of what? So if you write this, what happens here, students? So this becomes, so this is equal to k into 1 into 1, that is equal to k. Correct? So minus dr by dt, k anything to the power 0 is 1, anything to the power 0 is 1 into k means k. So dr by dt is equal to k means what? It is completely independent of concentration of reactant. So what is zero order means? The reaction in which the rate is independent of the concentration of reactants is called as zero order reaction. Okay. So students, the example for this is, okay, I'll write the example. Decomposition of NH3. Okay, how? So listen, NH3 is here, decomposed in presence of platinum gives N2 plus 3H2. Okay, students. If you write the rate expression here, so rate is equal to K into concentration to the power of NH3 0. Why it is not depends upon the concentration of NH3? You know, reactant is NH3. Then also it is not depends on the concentration of NH3. Why? Because so listen, in ammonia is a gas, you know, correct? This is also gas. This is also gas. This is also gas. How this reaction takes place? Here we are using platinum. Okay. So in the absence of platinum, this reaction is not feasible, is not taking place. Okay. Only in presence of platinum, this reaction takes place. That means the presence of catalyst. So catalyst means it is a solid. Okay. It has its surface. So this NH3 gas is deposited on the surface of this metal. How much NH3 is deposited? That much N1 3H2 is formed. Understand? That depends upon what? The surface area are absorbed by this NH3 of the platinum. Okay? The surface area of platinum which is absorbed by what? NH3. Means the rate of reaction is depends upon what? The surface area of the platinum. So it is independent of the concentration of NH3. Understand? Reactant is ammonia on the air, but the rate depends on what? Surface area of clotting. As this is a reactant, so this is not dependent on the reactant means of course this is a zero order reaction. So this is the example. So the reaction which is taking place in presence of any this gaseous substances, that is almost a zero order reaction. Not compulsory, must and should, almost a zero order reaction. Understand? So this is R you take 0, correct? Zero order reaction means concentration power is 0. So you take minus dr by dt is equal to, okay, sorry. K becomes what? K is equal to this minus dr divided by dt into 1 divided by r to the power 0. Correct? So you may take, if it is the n order reaction, you take n. Understand? Here 0, I am taking 0. Understand? This become 1 by r. Understand? So here dr means concentration divided by time into 1 divided by concentration to the power 0. Correct? Or if you have to write completely. Concentration divided by time into 1 divided by concentration to the power 0. Understand? So students, anything to the power 0, what it is? 1. So concentration means mole per liter. Correct? So this time means second. This is 1 divided by 1. That means mole per liter per second is the unit of rate constant for a zero order reaction. Unit of rate constant for a zero order reaction. Understand? Next. So I hope you understand what is zero order reaction means, which is independent of the concentration of reactants. Okay? So next we will discuss first order reaction. So second one is, what is first order reaction. So in this first order reaction, this rate becomes minus dr divided by dt is equal to how much? So minus dr divided by dt is equal to k into a to the power of x, b to the power of y. Okay, so here order x plus y is equal to 1. If x plus y is equal to 1, then it is a first order reaction. So the definition is next. The sum of the powers of concentration term is 1, then it is first order reaction. The sum of the powers of the concentration term is 1, then it is the first order reaction. The sum of the powers of concentration terms is 1. Understand? So here, example for this is, If I write the example, you will easily understand. So this is decomposition of H2O2 without catalyst. Okay. So students, here H2O2 you take gives rise to H2O plus R2. Understand? So here, how much H2O will form, how much O2 will form, that depends on what? How much H2O2 will decompose. If 1 mole of H2O2 decompose, 1 mole of H2O, half mole of O2 will form. Okay? If 2 mole of H2O2 decompose, then the 2 mole of H2O and 1 mole of O2 will form. Understand? So this one gives the reaction which tells about what? The concentration of or rate you take, that is minus dr means by dt is equal to K into concentration to the power H2O2 to the power of 1. Understand? So students, you listen, you may balance this reaction by multiplying with 2. Listen, this may be 2H2O2, 2H2O into 1 O2, correct? So if it is in this form, it is not like it is a second order reaction, it is simply a balanced reaction. But the rate is depends on what? Only the concentration of this H2O2. Understand? It is a balanced reaction only. So, because of that reason, so the rate, as I told you, no, x plus y may equal or may not be equal to stoichiometric coefficients, correct? May or may not. So here 1 is there, here 2 is there. So it is not equal. Understand? It is simply a balanced chemical reaction. So this is what? Minus dr by dt is equal to K H2O2 to the power 1. So as we come to this unit of rate constant for unit of K for first order reaction. Okay? So listen students, here what happens? Minus dr by dt is equal to K r to the power of what? This is r to the power of 1. Correct? Because it depends upon the concentration of the reactant. Listen, r, this is r to the power 1. Instead of H2O2, I am taking r here. Understand? So because general reaction. So if you consider this, then K becomes what? K is equal to minus dr divided by dt into 1 divided by r to the power 2. Correct? So this is concentration by time into 1 divided by concentration to the power of much? 1. Correct? So that means, so listen, here this concentration gets cancelled. Correct? Avoids the numerator. That is 1 divided by time. Time means second, that is second inverse. So the unit of rate constant is second inverse for first order reaction. Understand? So these units is very important for 1 mark. 0 order, first order, second order, everything. Okay, important for 1 mark. Understand students? So this is a first order reaction. The first order reaction means the sum of the concentration terms rise is equal to 1. If it is equal to 1, then it is said to be a first order reaction. Example is here. Understand? And the unit is there. Unit for what it is? Rate constant. Unit for what? Rate constant. Always remember, students, the unit of rate of a reaction is constant. Always it is concentration by time only. But unit of rate constant varies with order. Understand? Next. Third one is second order reaction. Okay, so second order reaction, again I am considering the general equation. AA plus BB gives rise to CC plus DD. Here this is the rate expression, A to the power of x, B to the power y, and order is equal to what? 2. Okay, so what is the definition in the reaction? Or in the reaction, the sum of powers of concentration term rise is equal to 2, then it is a second order reaction. And it is the second order reaction. Understand? So here, example for this is decomposition of HI without catalyst. Okay, so students, here HI decomposes means it should give H2 and I2. So students, listen, these two are gases, correct? This HI is a liquid. So here we are not using any catalyst, means we don't have any surface area to absorb this H2 and I2 gas. So that's why to balance this, HI is there, then it is half H2, half I2. That is not stable. So without catalyst, this is not possible. So that's why we require in 2 moles. 2 moles of HI decomposes without catalyst to form H2 and I2, then these become stable. Understand? So that means the rate means what? dr by dt minus dr by dt is equal to K into concentration to the power of HI to the power. So students, here the order of the reaction and the coefficient is equal. Understand? As I told you, the order of the reaction may or may not be equal to stoichiometric coefficient. In the before example, in the first order reaction, the coefficient and also order is different. But here, both the coefficient and order is same. So here, always the second order reaction means it is equal to the secondary powers of the reactants. Okay. So if we consider the unit of K for a second order reaction, what is the change here, students? Here the power 1 changes to what? 2. Correct? So here dr by dt is equal to K r to the power 2, because this is, so then this becomes 2. Correct? So listen, I write here. So K is equal to concentration by time into 1 divided by concentration square. 1 divided by concentration square. Correct? So in one concentration and concentration square gets cancelled, it is equal to 1 divided by time into 1 divided by concentration. Correct? So 1 divided by time means 1 by a second into 1 divided by concentration means mole per liter. Understand? So here mole is there, it is in the denominator. If we go to numerator, that is mole inverse. Liter inverse is there. If we go to numerator, that is liter. Second is there, that will become second inverse. Understand? Mole inverse, liter, second inverse is the unit of second order reaction. Understand? So you may calculate it for so many types. You may calculate it for n also. You may calculate it for 3. So third order means here it is 3, here 3, it becomes 3, it becomes square, then you can check. Okay? So you consider this is the unit for a rate constant. If it is a 0 order, you keep here 0. If it is a first order, keep here 1. If it is second, 2, 3, 4, 5, 6, you can calculate it until nth order. Okay, so this is the equation. If you know only this much, you can easily calculate the order of a unit for a respective order of a reaction. Understand? So the next one is pseudo first order reaction, so which is very important for 2 marks. So fourth one, which is important for 2 marks, pseudo first order reaction. Okay, students. So listen. First, I consider the respective reactions here. Assume the ester hydrolysis of ester. Okay. So example is first I will give example, then I will say definition. Hydrolysis of ester. So I take example. So listen. CH3 COO C2H5 plus H2O. Okay, gives rise to, here the bond breaks takes place, CH3 COOH plus C2H5OH. CH3 COOH plus C2H5OH. So this is hydrolysis of ester. This is ethyl ester. Okay, H2O, then it forms acetic acid and alcohol, ethanol. So students here, listen, initially at time 0, assume this one is 0.1 mole. Okay, this one is 10 mole. This one is only 0.1 mole. This one is 10 mole. And this one is 0.0. 0. When time is equal to 0 initially. Next, after time x, it completely reacts. This becomes 0. How many moles are there? 0.1 mole is there. 0. So listen, 1 mole of ester combined with 1 mole of water to give 1 mole of acetic acid and 1 mole of ethanol. So here we have 0.1 mole of ester, 10 mole of H2O, but only the reaction can possible for only 0.1. So here 10 minus 0.1 means 9.9. Correct? So 9.9 left here, only 0.1 mole reacts. Are you with me? This is initial minus it reacts. Next, 10 minus 0.1. Okay, this is 0.1 minus 0. This is 0.1 minus 0. So final you take, it becomes 0, it becomes 9.9, this becomes 0.1, this becomes 0.1. So students, the product formula here is depends on what? The number of moles of ester present, not the number of moles of water present. But this reaction can take place only in presence of what? Water. Okay, this reaction takes place in presence of water, but the product concentration is depends on the concentration of this ester alone. Understand? So here rate is equal to what? Is directly proportional to concentration of CH3COOH and also this concentration of H2O. Okay, but this H2O present in excess. It is a solvent. It present in excess means the concentration of H2O is neglected. Understand? So the rate changes to what? Rate is equal to K I take the concentration to the power of COOH to the power 1 and H2O to the power 0. Understand? So here, what is the definition of this pseudo first order reaction? Mean it is a bimolecular reaction. Bimolecular reaction made to behave like a first order reaction. Understand? It is a bimolecular reaction, but it is made to behave like a first order reaction. Hence, it is called a pseudo first order reaction. What is the reason? As I told you, this is an example. This is hydrolysis of ester. Here, the product concentration is depends on only the concentration of ester. But to complete the reaction, we require both ester as well as water. So here, water concentration is neglected. Understand? So that's why this is CH3COOH to the power 1, H2O to the power 0. H2O is present, but it is not dependent on concentration of H2O. Then power, if we add power means 1 plus 0, we will get 1. Understand? That's why it is a pseudo first order reaction. Why? Because it is a bimolecular reaction, but its order is 1. It forcefully behaves like a first order reaction. It is made to behave like a first order reaction. So students, the unit for pseudo first order reaction is also same as the first order reaction. Understand? So this is all about the different orders of a reaction. Okay, unit is same as first order reaction because you know unit of pseudo first order means the order is 1. Order is 1 means what? It is also equal to 1, it is also equal to 1, it is also equal to 1. These two is cancelled, it is 1 by 10 means only second inverse. You know, you already calculated for the unit for a first order reaction, that follows for the pseudo first order also. Both are first order reaction, understand? So this is all about the different order of reactions, and this one is very, very important. That is definition with any one example. Not this much explanation. By writing this and writing this, rate expression. This much is enough. Then you get 2 marks. Understand? So this is all about the different types of order of the reactions and their units. In the tomorrow's class, I will repeat it again, and also I will write the unit of a different orders for us in a separate table, and I will explain molecularity of the reaction. Another one topic is the difference between order and molecularity. Okay? For today's class, this is enough. Thank you.